Okay, so the video for today is going to come in two parts. We're going to do some long division first. We're going to start with some numeric long division, and then we're going to do polynomial long division. But I want to show you the numeric part first. The second video I'm going to do tonight or today is on synthetic division, and we'll show you an alternate method so that if you can do synthetic division, I would encourage you to, but if you have to use long division, that's what this video is for, so you know how to use it. So we're going to do a little reminder on how to do long division. I'm going to start with some numbers here. We're going to use long division to divide 8,905 by 7. Now, as a fraction, this could be written as 8,905 over 7, so just so you're aware of what the fraction might look like. But I'm going to translate this into a division problem, not a decimal. 8,905 divided by 7. So what we're going to do here is take this 7 and see if 7 will divide into 8. 7 goes into 8 one time, so now we're going to start the process of actually doing the division steps here. So 1 times 7 is 7, line it up and subtract it. So 8 minus 7 is 1. Now I'm going to bring down the next part of the problem here, this 9, and I'm going to start the division all over. So now I'm going to take 7 here, divided into 19. So 7 goes into 19 2 times. 2 times 7 is 14, and I'm going to subtract again. 19 minus 14 is 5, and I'm going to bring down the next number in our order here, so that gives me 50. So now I'm going to take this 7 and divide it into 50. So 7 goes into 50 7 times. 7 times 7 is 49. Got to multiply. And we're going to subtract here, so that leaves us 1 left over. Bring down the last number in our original problem, so this is 5. And we're going to take this 7 here one more time and divide it into 15. So 7 goes into 15 2 times. 2 times 7 is 14. We're going to go ahead and subtract one more time. We get 1. Now, some of you might go, oh, I know what to do next. And you might say, oh, you put a decimal, and then you put a 0, and you can keep going. And you are 100% right. But for our purposes today, I'm not going to do that. Okay? This is your remainder. And with your remainder, all I want you to do is make a fraction out of it. So we're going to take this remainder of 1, and the fraction becomes 1 over 7. Now, why am I using 7? Well, because I was dividing by 7. So your denominator here for this fraction becomes whatever you were dividing by, okay? So if we divide 8,905 by 7, we get the answer 1,272 and 1/7. All right, so that's the numeric example to kind of refresh your brain about how it all works. And now we're going to move on to some polynomial examples. All right, so on the note sheet, I am on page 2. All right, and page 2 says to divide each pair of polynomials using both long division and synthetic division. Synthetic is what I'm going to do in the next video, so for right now, we're just going to work on the 2 long division problems. So problem number 3, part A, we are supposed to take this pretty little cubic function here, this 4-term polynomial, and we are supposed to divide it by our first degree denominator here, a linear function of x plus 10. So first thing I want to do is set up a division problem. So I am dividing x cubed plus 6x squared minus 30x plus 102, and I'm dividing that by x plus 10. All right. Now, with the last problem, with the numeric example, we did 7. We were dividing by 7, and so we kept looking for how many times does 7 go into those values. What we're going to look to do here is not look at both x and 10. We just look at the leading term here. So what I'm focused on here is x, and I want to know how many times does x go into my leading number of x cubed. So if you want to, off to the side, you can make a little note. You are taking x cubed, and you are dividing by x. Well, that gives you x squared, okay? So that's the value that goes on top. All right, now it doesn't matter because we're not dealing with numeric values here. It doesn't matter how you line up your polynomial in the numerator, or in your answer. Okay, what does matter is that you now take that x squared and you multiply it times both parts of what you're dividing by here, which in this case is x plus 10. All right. When we distribute, we're going to get x cubed plus 10x squared. So these two little terms here become what you line up here with this original polynomial. So we've got x cubed plus 10x squared. And now I need to subtract. But when I subtract, I need to subtract both parts of this. So you could either just do the subtraction in your head, or if it helps you, you might want to distribute the subtraction just so you don't lose track of signs. All right, it's up to you totally. So I'm going to do x cubed minus x cubed. They're going to cancel each other out. Then I'm going to take 6x squared minus 10x squared. So that's going to give me negative 4x squared. And I'm going to now bring down the other pieces of my original polynomial, the other terms. So negative 30x plus 102. And I'm going to start the process again. So I am going to take x, and I'm going to divide it into negative 4x squared. If it helps to keep everything straight for you, put this off to the side. Make a little note. You're taking negative 4x squared divided by x. Well, that's just negative 4x. Now you're going to take that negative 4x, you're going to put it up top as part of your answer, and you're going to distribute it to the x plus 10. So when we distribute, you get negative 4x squared minus 40x. So let's line those up. Negative 4x squared minus 40x. And we need to subtract, but again, it's both pieces, not just one. So negative 4x squared minus negative 4x squared, those two bits are going to cancel. Negative 30x minus negative 40x. Be really careful with your signs. This turns into 10x. And then again, I'm going to bring down that plus 102. And we're going to start it again. All right? We're not out of polynomial yet. So we're going to take x and divide it into 10x. So again, you can always put this off to the side. If you can keep track of it in your head, awesome. Do it in your head. All right, there's 10. So that's a positive 10. So when I put it as part of my answer, we're going to go plus 10. And I'm going to take 10 and distribute it times both of the x and the x plus 10 pieces of what I'm dividing by. So 10x plus 100. Let's go ahead and line that up. 10x plus 100. And one more time, we're going to subtract both parts. So let's see, 10x minus 10x, they'd cancel out. And I'm going to pause here for a second and draw your attention to something if you haven't noticed it yet. Every time we go from one step to the next in this problem, these leading terms have to cancel out with polynomial division. So please make sure that's happening. If it's not, something's going wrong with your multiplication or your division, but something's going wrong. All right, back to our problem here. We've got 102 minus 100, which leaves us an answer of 2. Now, we have officially run out of polynomial. There's nothing else here, so you can't put like a little decimal point and add some zeros. But what you can do is now write the remainder as a fraction. So this is a positive 2. So we're going to do plus 2 over the pieces that you were dividing by. And in this case, we were dividing by x plus 10. So x plus 10. So your answer to problem number 3, part A, using long division is x squared minus 4x plus 10 plus 2 over x plus 10. Okay? So that's 3A. Let's take a look at what 4A has in store for us, because it's a little different. Okay? And the reason it's a little different is, and I'm going to show you, I'm going to actually scroll back up to 3a really quickly here. All right. In 3a, you may notice that we had the highest degree in the numerator here was x cubed. Then the next term had x squared. The next term had x. And the last term was your constant. That's great. That's what we need. We need to see all of those terms represented in our problem. But if we look at 4a, we go from x cubed to a constant. So we're missing some pieces here. So what we're going to need to do is create some placeholders. So we've got x cubed, but what we don't have is we don't have an x squared. So the placeholder is 0x squared. We also don't have an x term. So we're going to add plus 0x, and then we're going to finish it with the minus 20 that we did have. Now, what we're dividing by here, x minus 3, does have all of its pieces, right? X then constant, so that part just goes at the end. We're dividing by x minus 3 here. And now the steps are the same. Now, for this one, I'm not going to show the little work off to the side. If you have questions or concerns, just drop me a message, all right? But we're going to keep starting with this leading term here, this x, and divide it into this leading term, x cubed. So x cubed divided by x is x squared. Now I'm going to take x squared and multiply it times both parts of what I was dividing by. So x cubed minus 3x squared. Now I need to subtract both parts. So x cubed minus x cubed, they're going to cancel out. 0 minus negative 3x squared is going to be positive 3x squared. Bring down the other pieces of your polynomial. Start it again. Divide x into 3x squared. So if we do that division, we're going to get positive 3x. Let's go ahead and multiply it. 3x times x is 3x squared. 3x times negative 3 is negative 9x. And now we need to subtract again. Always making sure that when we do the subtraction, these leading terms completely cancel out. So 3x squared minus 3x squared, yep, those cancel. 0 minus negative 9x is going to be positive 9x. Bring down the minus 20. And we got to do the division one more time. So take our x value here, and we're going to divide it into 9x. So 9x divided by x is a positive 9. All right. So now I need to distribute. 9 times x is 9x. 9 times negative 3 is negative 27. But I need to now subtract both pieces here. Okay. So 9x minus 9x, yep, that cancels out like it should. Then we've got negative 20 minus negative 27. Be really careful when you have all those negatives going on. What you really have here is negative 20 plus 27. If you want to distribute, you could see it that way. And so that gives me just 7. So now I'm going to take this 7 and turn it into my fractional remainder. So it's going to be plus 7 over x minus 3. And that is our final answer for this division problem. All right, so this concludes the video on long division. All right, let me know if you have any questions or concerns. If you have any issues with any of the steps, send me a message, send me an email. All right, the next video is going to be on synthetic division, and we'll see if you can find that process maybe a little bit easier.